All right, what does this symbol mean?
Multiply. No.
Nope. Remember, we can rewrite it as, right? Composition of functions. We're going to throw the function g of x into the r function. So I'm going to do it over here. I'm going to have a lot of room. I'm going to make r g of x. Okay? Now I'm going to put in what g of x is. Well, g of x equals this. So I'm going to put that in there. X squared plus 4. Okay? So now I go to my r of x function, and I'm going to write it down for you. Okay? That's my r function. So wherever there's an x, I'm going to plug this into it. So I'm going to find r of x squared plus 4 is equal to x squared plus 4 minus 4. At this point, I'm going to simplify. Plus 4 minus 4 is 0. And what is the square root of x squared?
For their answer, they have absolute value.
Of x. Okay, yeah.
Oh,
You
that's
have
what
to
it was
put that in
there.
there.
No, you don't have to worry about that.
How do you write it again? Sweet.
Any other ones? If you have something like that, yeah, I would probably find f of x, and then I would find t of x together. Okay. Especially when they're looking for a number. If they're trying to find f of 2, I would definitely do it this way. Well, let me give you an example as long as you ask that. I'm going to come up with f of x is equal to x plus 4. T of x is x squared minus 4. In this example right here, if I was to find f plus t of x, all I'm going to do is add those two functions together. All I'm going to do is take x plus 4 plus x squared plus 4 minus 4. I'm going to add them together. The 4's are going to disappear. And I'll have x squared plus x. Now, if I changed it and I wanted to find, let's make it easy, f plus 2t, of 3, I really wouldn't add these together first, then plug a 3 in. I would basically find f of 3 plus t of 3, which would be 7 plus 5, which is 12. That makes sense?
Yep.
That's the difference of the two. Okay, number 84. Here's your function, 3x minus 5. Well, is this a function? Why? That's the question. How do you know this is a function? I could ask you very easily on a test and say, why is that a function? What would you do? I'd graph it myself. Or you can remember back into the olden days when you used to graph, you would go 1, 2, 3, 4, 5, up 3, 1, 2, 3, over 1. Does that pass the vertical line test? Okay. What's the domain of this? What's the range of this? Perfect. There you go. All right. To find the inverse, remember the first thing we do is we make that into a y. Then we flip them. Then we solve for y, so I'm going to add a 5, so that becomes x plus 5 equals 3y. Now I'm divide by 3, so I'm going to write it this way, x plus 5 over 3. So now I'm going to rewrite it in my function inverse form, which is x plus 5 over 3. Now the question, is that a graph? Let me rewrite it for you. We're going to decompose this. Remember when, hey, this morning, oh, you're seniors, you didn't have to do it. We gave a worksheet out for adding fractions. What did you need to have to add fractions? Common denominator. Well, the common denominator is 3, so I could write this as x over 3 plus 5 over 3. And I really don't like it written that way, so I could rewrite it as 1/3 x plus 5/3. Now can you see if it's a function? Yeah, it's just going to be a straight line. Okay. However, it doesn't always happen. If the original one's a function, the inverse won't always be a function. That'd be a great third-page question, too. I'll give you one hard one, right? Sure I do. Just one. Oh, no. Okay. That's a good question. If I were to give you a question on a test, what is a function? What's the first thing you should do? Graph it. Right off the bat. Okay? And then do the vertical line test, okay? You'll realize, really, there aren't that many not functions I can come up with. Everything in calculus is based on functions, so I'm going to hit you with functions, not the other stuff.
Just put yes.
No, graph it.
Okay.
If you see something really goofy, I don't even know how you would even graph something with a y squared in it. I don't know. There's a certain graph that's called this in the math world. It's a hyperbola. Would that be a function? No. This is what happens when your y squares get squared. When your y's get squared. Don't worry about it. You won't see those. I would ask you a question like, basically what I think I would like to do is, I would probably do, this is a really easy example. I'd probably jump a whole bunch of questions in on it. One, is this a function? Yes or no? What is the domain? What is the range? That's what I would ask you. I'm not going to just say one question, is it a function? Okay. Could we do the inverse of that one? That's pretty tough. I probably wouldn't give you that. I know I wouldn't give you that. Okay. This one, by looking at it, you should know this is what? A parabola. Would this be a function? Yep. Okay. After that, you'd have to figure it out. Or I could just give you a graph. Hard for me. Now, let's just do one for you on your own calculator. I can't draw one that well for you to see. Let's go with f of x is equal to x minus 1 over x minus 7. The questions I would be looking for this is this a function? Okay, and I'd ask your domain and your range. Is this a function? Yeah. It passes this vertical line. Remember, if you have the older calculators, this line is easier. You don't have it. Okay? But this is not the graph, so don't say it fails right there. So it is a function. What would the domain be? Negative infinity to...
7.
Does it include 7? Do you have a parenthesis or a bracket? Parenthesis. It cannot include 7. And then it goes from 7
Infinity.
infinity. Okay? All right, cool. I will not ask you a range on this one, 'cause this would get kind of tough on the range, so forget I asked that
What
one.
is the range?
Okay? Well, we have to figure out what our horizontal asymptote is.
I don't know.
I know, funny word, but they all laugh. Look at them. Okay? Try those. Okay, so you want to find f plus t of x.
Yeah.
And now, since I'm not finding a number, I'm just going to add my functions together. So I have to take 2x plus 3 plus x minus 3 over 2. How in the world would I do that?
Don't you put a common denominator?
You'd find a common denominator. So I would multiply the top and bottom by 2. Bring that through 4x plus 6 plus, I always put parentheses there, over 2. And then I would say, well, 4x plus x is 5x. 6 plus a negative 3 is positive 3. And I wouldn't go any farther than that. And then again, like we talked about earlier, if you wanted to find it of 2, then I would just plug them in. It'd be a lot easier. That would be 7 plus negative 1/2, which would be 6 1/2, which is 13 halves.